Okay, this is my second version of the same video. Okay, my name is Dan Foley and I'm going to be teaching a brief class in how to calculate the volume of a rectangular tank in cubic feet and then converting that answer into gallons. If you'd like to know a little bit more about me, I'm going to be putting another video out shortly kind of about my career. Anyway, you know, this is really an important calculation to know how to do. We use it all the time at water plants and wastewater treatment plants and all that. We calculate detention times with it. We calculate contact times. It's used in confined space calculations to determine the number of air exchanges, all kinds of things. So it's really important to know this. If you're going to take a class, it's really important to know to pass the class. If you want to become a certified operator, you're going to need to know it. If you're going to become an engineer, you're going to use it a lot. So anyway, it's a great calculation to know. Anyway, I'm going to try and knock this out in about 3 minutes. I'm going to try and keep it really light, so I don't want to bore anybody. But anyway, the title of this whole thing is calculating the volume of a rectangular tank. We're calculating the volume of a rectangular tank. All right. Now the formula is real simple. It's length times width times depth. All of these numbers, if you're here should be in feet. And the reason you wanted these all in feet is you'll get an answer in cubic feet. And if for some reason you wanted to get an answer in cubic inches, then you would convert all these to inches. Typically in the field we use feet all the time. From that point, okay, now we have length times width times depth expressed in feet, gives us an answer in cubic feet. Then we multiply that times 7.48, which is the volume of liquid it contained in 1 cubic foot of space. And that gives us the answer that we were looking for in gallons. So anyway, what I've got here is a little sample problem. I'm going to draw a tank. First thing I'm going to do though is, one of the benefits of this equation here is this is length and width. You can calculate square footage. Square footage, which is length times width. And that would give you an answer equals area in square feet. Okay, I'm going to leave that out. But anyway, if you wanted to, you could calculate the area of square feet. Anyway, I'm going to call the width of this 25. I'm going to say the width is 25, and I'm going to say my depth is 12. Okay. Now, here's the tank. Kind of not to scale, really. Anyway. And I'm going to call that, 12 feet, 80 feet long. Okay, so we've got a tank that is, the width is 25, depth is 12, length is 80. Okay, so length times width times depth, and we're going to go ahead, length 80 times a width of 25 times a depth of 12. Okay, now that, assuming these are all expressed in feet, equals 24,000 cubic feet. Okay, so that is the volume of that tank, 24,000 cubic feet. Okay, now if I wanted to convert that value to gallons, I'm going to multiply it by 7.48. Okay, which, as I mentioned above, that is the number of gallons that would fill 1 cubic foot of space. Okay, now I have 179,520 gallons. in that tank. So if I had a tank that's 25 feet wide, 12 feet deep, 80 feet long, it's going to contain 179,520 gallons. Anyway, that's a basic calculation. We use it all the time. Ultimately, what we'll get into is detention times, which is detention times, or DT for short. We'll use it for CT, contact time, modal contact time. These are all equations that you'll hear a lot in the water field, environmental field, and things like that. But anyway, this is just a start. This is basic calculation here. This is one of the first videos I've shot on how to do it. Someone on how to do all this stuff. Anyway, if you like what you saw, let me know. You can email me at dfoley@dtmfoley.com. Hope you like it. Again, first effort. Please bear with me. Talk to you later. Goodbye.